Number 6 states, find the length of the shortest path from point 3, 5 to the point 8, 2 that touches the x-axis and also the y-axis. So the problem states from A, it's going to touch the x-axis. And then it's going to touch the y-axis. And then it's going to go to B. So we need to find the length of this line. So first, we're going to flip point A over to x-axis. And we're going to call this A prime. Since we flipped over to x-axis, 8 is going to stay the same. But now it's going to be -2. We're going to call this point right here C. And AC is equal to prime AC. We flipped over to x-axis because we want to find a straight line in order to find a distance easier. Now we're going to flip point B over the y-axis. We're going to call it B prime. Now 5 is going to stay the same, but the 3 is going to be negative. And then where we reflected it, we're going to call it D. Now it's the same concept as A and A prime. So BD has the same length as B prime D. Now all we have to do now is find a distance from prime A to prime B. And this is because since we stated AC equals A prime C, we'll find this length, we'll find CD, and since prime B and D equals BD, then we'll find this distance here. So the distance formula is the square root of x sub 2 minus x1 squared plus y sub 2 minus y sub 1 squared. So the distance of A prime B is going to be the square root of -3 minus 8. That's going to be squared plus 5 minus -2. And since it's a minus and negative, we could just make it +2. So the distance of AB of prime AB will be the square root of 11 squared plus 7 squared. Once again, distance will be 11 squared is 121 plus 7 squared, which is 49. So the distance of prime A and prime B is equal to square root of 170. And that will give you the shortest path from point A to point B that also touches the x-axis and the y-axis.